Welcome back. This is Mr. Hassan's Maths channel, and this is now question number 7 from the June 2022 International A-Level Edexcel Pure Mathematics P4 paper. Now this question here is about parametric equations. So here we're given a curve C, which is defined by this pair of parametric equations: x equals sine t minus 3 cosine squared t, and y equals 3 sine t plus 2 cosine t, where t is between 0 and 5. So this is basically an equation which is defined with a third parameter t. So if you were to just, like, there was a question that somebody would ask me in one of the comments, and they couldn't understand how the t comes into this. Now basically, if you were to plot this graph, for example, what would you do? You'd have an x value, or let's say we'll have a t value. You'll have a table with a t value, and you'll have an x value, and you'll have a y value. Okay, that's how you would go about this. So if you were to plot this, you don't have to do this for this question. I'm just trying to lay some foundations for some students who don't have an idea of what this parametric stuff actually means. So let's, for example, we take t between 0 and 5 going up in 1 units, for example. So you've got t is 1, 2, 3, 4, and 5. Now, to find the x coordinate when t is 0, you just replace t with 0. So that will be sine of 0, which is 0, minus 3 times cosine 0 squared. Now, so that will be 0 minus 3 times, that's minus 1 squared, because cosine of 0 is 1, sorry. So it's going to be 3 minus 3 times 1, which is going to be minus 3. That will be 0 minus 3. So x is minus 3. And when t is 0, this will be 0, and this will be 2 times 0, which is 2. So that's the coordinates. So when we can say when t is 0, the coordinates of the point will be given by minus 3, 2. And so if you want to find what the coordinates of the point is when t is equal to 1. Okay, so when t is equal to 1, oops, sorry, we've already got 1 there. T is equal to 1, you would put 1 into this equation. So you'll have sine of 1 in radians minus 3 times cosine squared of 1. Okay, and that will give you your x and y coordinates and so on. That's how you would find the coordinates of these points. Now that will be in radians, so it's going to come out some decimals, so I'm not going to show you. But basically, when t equals 1, you put 1 in here, you find the x coordinate. You put 1 in there, you find the y coordinate. That will give you the x and y coordinates when t is 1. And the same thing with when t is 2, when t is 3, when t is 4, when t is 5. And then you can plot those points and draw your graph. That's how parametric equations would work if you were going to plot them. But we don't need to do that here. I just wanted to, as I say, lay some foundation, especially for students who are asking, where does the t come into it when you're plotting? All right, now, so the question asks us to show that dy dx equals 3 when t equals pi. All right, so that's, we have to find dy dx. All right, now we don't have y in terms of x. Making y in terms of x, changing this into a Cartesian equation where you've got y equals some function of x, is not going to be very easy here, right? So what we're going to do is we're going to find dy dx using parametric equations. So we know that dy dx using the chain rule would be dy dt multiplied by dt dx. Now we can find what dy dt is, and we can find what dx dt is pretty easily, and then multiplying dy dt by dt dx, which is the reciprocal of dx dt, we can then find dy dx quite simply and then show that this is true. So first of all, let's get dx dt. Now dx dt, differentiating sine t gives you cosine t. That's not too difficult. And this is 3 times cosine squared t. So let me just write this as in this form so we can see exactly what's going on. We're going to use the chain rule here. This is cosine, it's like cosine t all squared. That can be written as cosine t all squared. So the main function here is something squared. It's something squared. It's like you could say a polynomial type of function, all right? And inside the function is this trig function cosine t. So how do you differentiate something which is a polynomial? You multiply by the power, and you take 1 from the power. So this is going to be minus 6 times cosine, this is cosine t, all right? Minus 6 times cosine t times the differential of what's inside the function. Okay, what's the differential of cosine t? It's minus sine t. So it's times minus sine t. Okay, so this is like 3 times cosine t all squared. So you got 6 times cosine t times the differential of cosine t, which is minus sine t. So we can say dx dt is going to be given by cosine t. You're going to have plus 6 times, you can say sine t cosine t. You can leave it like that, there's no problem. We could even use a double angle formula for this if you want to. But dt dx, therefore, which is what we're going to need, is 1 over this. So it's 1 over cosine t plus 6 sine t cosine t. Okay, so as I said, I could leave it like this, or I could make this into, this can be sine t, 2 sine t cosine t is going to be sine 2t. So I could make that into a double angle, but I don't need to here. No need to do that. Okay, and we know that y is equal to 3 sine t plus 2 cosine t. So y is equal to 3 sine t plus 2 cosine t. So dy dt is not so difficult. That's going to be 3 cosine t. Differentiating cosine to give you minus sine t. That's minus 2 sine t. So we can now say dy dx is dy dt, which is this, 3 cosine t minus 2 sine t divided by, because it's multiplied by 1 over this, that will be cosine t plus 6 sine t cosine t. So they're saying show that dy dx equals 3 when t equals pi. So let's see what happens when we put t equals pi. We're going to get dy dx is equal to 3 cosine pi minus 2 sine pi over cosine pi plus 6 sine pi cosine pi. So cosine of pi, as you know, is minus 1. Okay, cosine of pi is minus 1. That's going to be minus 3. The sine of pi is 0. The sine of pi is 0. Okay, I drew that wrong. It's not this graph at all. Okay, this is the sine curve. The sine of pi is 0. Okay, so that's going to be minus 0 over cosine of pi is minus 1. And you're going to have, that's going to be plus 6 times 0 times minus, that's going to be 0. So you end up with minus 3 over minus 1, which is 3, very clearly. Okay, so therefore we can say when t equals pi, dy dx is equal to 3. So we've shown that very clearly here, and that's part A. And you'll notice that in the new kind of style of questions that they have for Edexcel in all the different units now, they're making the subsequent parts of the question accessible even if you couldn't do the first part. So for example, now we know that dy dx equals 3 when t equals pi. Even if we couldn't calculate that, if we couldn't get these 4 marks for this question, you know, this is going to be used now, as you can see in the next part of the question, because they've said to us the point P lies on C where t equals pi. And we know that when t equals pi, dy dx equals 3, that's given to us in part A. So we can use that result to continue now, because it says find the equation of the tangent to the curve at P in the form y equals mx plus c, where m and c are constants to be found. So if we know how to deal with straight line graphs, we understand that dy dx is the gradient when t equals pi. Okay, we will be able to continue and solve this question. So we're not going to lose these marks, okay, because of not understanding how to do part A. All right, because that's what you need. What we need to one of the things we need to answer this question is we need this information here, and we also need something additional, which I'll show you. So we're going to find the equation of the tangent. The tangent is a straight line. Okay, it's a straight line which just brushes past the curve at a particular point. So a straight line that brushes past the curve at a particular point. So it has the same gradient as the curve at that point. So we can say at P, the gradient is equal to 3. Okay, at P when t equals pi, dy dx equals 3. Okay, that means the gradient is equal to 3. And we can say at P, we have x equals sine of pi minus 3 times cosine of pi squared. Remember, cosine squared pi, cosine squared t means cosine t all squared. So x is equal to, we know the sine of pi is 0, the cosine of pi is -1, so that's going to be -3, so x is -3, and at P, we can say y is equal to 3 times sine of pi plus 2 times cosine of pi. So y is going to be 3 times 0, which is 0, plus 2 times pi, which is going to be, as we said, minus 1. Cosine of pi is negative 1. So this is minus 2. So we can say that the coordinates of P are negative 3 and negative 2. And we can say the gradient of P, or the gradient of the curve at P, is going to be 3. The gradient at P is equal to 3. So we can now use whichever form we like. I like to use y minus y1 equals m times x minus x1. Some people like to just use y equals mx plus c directly. This is y minus minus, this is the y coordinate, so it's minus 2 equals m, which is 3 times x minus minus 3. So you end up with y plus 2 equals 3 times x plus 3. So y equals 3x plus 9 minus 2. 3x plus 9 minus 2. So y is equal to 3x plus 7. That's the equation of the straight line. Okay, the tangent. Or we could have used this method here where we take this as y as minus 2, m as 3, x as minus 3. And we say, okay, that's minus 2 equals minus 9 plus c. Add 9 to both sides. C is equal to minus 2 plus 9, which is 7. Therefore, y equals mx, so it's 3 times x plus 7. Whichever way you want to do it, that's fine. Okay, so there we have the equation of the tangent at the point P where t equals pi. So that's part P done, right? So that's, again, as I mentioned, if you couldn't do part A, don't give up. Look at part B. And all the questions you'll find now in the new type of style of questions for International A-Level, you find that understanding part A doesn't necessarily, mean that you won't understand part B if you didn't understand part A. So if you didn't understand part A, you couldn't get the answer. It doesn't mean you won't be able to get part B. And the answers, or what you need from part A, is normally now kind of like given to you. All right, so you're given most of it, all of what you need, and you can use what they've given you to salvage some marks from the question by understanding how to do this part of the question. If you understand how to do this part, then don't just give up if you can't do part A. That's my point. All right, very important. All the questions now are like that. All right, now for part C, it says, given that the tangent to the curve at P cuts C at the point Q, show that the value of T at the point Q satisfies this equation. So we know the equation, the tangent to the curve at P is y equals 3x plus 7. All right, so we got to show that the value of T at the point Q satisfies this equation. Okay, so basically what it's saying is this line is going to meet the curve at this point, okay, Q. So we got to show that if I solve these two equations simultaneously, if I solve this equation with this equation simultaneously, then I should end up with this equation. And how do you solve them simultaneously? Well, you can see we're only one left with t's. So what I can do is simply replace the y, just use substitution, just like when we solve simultaneous equations. Replace the y with 3 sine t, 3 sine t plus 2 cosine t. So I'm replacing the y over here with what y is equal to, equals 3 times, and I'm going to replace the x with what x is equal to, which is sine t minus 3 cosine squared t, and I've got plus 7 at the end. Now, if I simplify this, this is what we should get. Let's see what happens. We got 3 sine t plus 2 cosine t. 2 cosine t equals 3 sine t minus 9 cosine squared t plus 7. Now let's bring everything on one side and make it say equals 0. Let's put everything on this side because 9, this term wants to be positive, as you can see. So I'm going to add 9 cosine squared t to both sides. 9 cosine squared t. I've already got 2 cosine t. I've got plus 7, take away 7 from both sides. Now on this side I've got plus 3 sine t. And this side I've got plus 3 sine t, which I have to take away from both sides. I've got minus 3 sine t equals 0. As you can see, these cancel out, leaving us with what we require. 9 cosine squared t plus 2 cosine t minus 7 is equal to 0. And that's exactly what we had to show. Okay, so there's the answer to part C of this question. That's exactly what we had to show. Okay, so that's that question done. So you simply solve the equation of the tangent with this simultaneously. Okay, so whatever your x is, you put in place of x. Whatever y is, you put in place of y. And then you see it simplifies to what we found. Now for part D. It says, hence find the exact value of the y coordinate of Q. So again, even if you couldn't do part C, or we got part B wrong and part C was wrong, whatever, and we couldn't get this, well, they've given us what we should have got. So again, we can use this to get the answer to this question. Now we know that this equation here represents when the tangent y equals 3x plus 7 intersects with this curve. Right, so if I solve this equation, I will find the points of intersection. So if I take 9 times cosine squared t plus 2 times cosine t minus 7 equals 0, and I say, for example, let cosine, for example, let's not use x here because there's x and y. Let's let u equals cosine t. All right, so therefore you're going to have 9u squared plus 2u minus 7 equals 0. Now let's try to solve this equation, this quadratic equation here. We have 9u squared and we have minus 7. When you multiply them, you get negative 63u squared, and you need to have a sum of plus 2. Okay, so again, it's going to be 9 and 7, isn't it? It's going to be plus 9u and minus 7. So this will give us the common factor here is 9u. So 9u times u is 9u squared. 9u times plus 1 is 9u, and u times minus 7 is minus 7u. That should be u there. So we end up with 9u minus 7 and u plus 1 equals 0. So we can say u is equal to 7 over 9 and u equals negative 1. So what we can say here now is cosine t is equal to 7 over 9, and cosine t is equal to cosine t, is equal to negative 1. So if I solve this equation, I say t equals inverse cosine of negative 1. So t is going to be pi, and now that's the coordinates of P. We want to find the y coordinate of Q. So we can say that, all right, let's see for Q. We know that for Q, y equals 3 sine t plus 2 cosine t. Okay, so let's try to find out what this is. It says find the exact value of the y coordinate of Q. Now, if I find, one of the problems here, if I find inverse cosine of 7 over 9, radian mode, if I find inverse cosine of 7 over 9, what's going to happen is, it won't give you an exact value, and I want an exact value. So there's a little trick to this question. See, it won't give you an exact value, so we can't use, that method here. So what I'm going to do is, what I need for the y is I need y. We know y is equal to, as they told us, 3 sine t plus 2 cosine t. So 3 sine t plus 2 cosine t. Okay. So now, we know that cosine t is 7 over 9. So I can replace this with 7 over 9. That's no problem. But I need to find an expression for sine t. Now, I know that sine squared t plus cosine squared t equals 1. And I know that sine squared t plus 7 over 9 squared is therefore equal to 1. So I can say sine squared t is equal to 1 minus 7 over 9 squared. So let's work out what that is. Sine squared t is 1 minus 49 over 81. Okay, so that's going to be like 1 minus 49 over 81, which is going to give us 32 over 81. So sine squared t is equal to 32 over 81. So therefore I can say the sine of t is equal to the square root of 32 over the square root of 81, which is 9. And this is like the square root of 16 times the square root of 2. So this is like 4 root 2 over 9. So sine t is the same as 4 root 2 over 9. Okay, that's what the sine of t is. So we can now say y is equal to 3 times 4 root 2 over 9 plus 2 times 7 over 9. Okay, so we have the exact value of cosine t, the exact value of sine t. So y is going to be, this is going to be 12 root 2 over 9. I kept this because I have a 9 there as well. Plus 14 over 9, so I can now add these together. So y is going to be 12 root 2 plus 14 all over 9. And there's the exact value of the y coordinate. They didn't ask us for the x coordinate, only for the y coordinate of q. Now what happens if we want to check to see if we've got the right answer? Okay, if we want to check to see if this is the right answer and we've got time, we want to make sure that we haven't made a silly mistake somewhere over here. Well, what we can do is we can take this value of cosine t, okay, and we can find what t is by using our calculator and then seeing if that value of t gives us the same as this when we substitute it back into the original equation. Okay, so here we have the value when we solve this equation. This is the part that we needed, cosine t equals 7 over 9, and we use this method to get the exact value. But supposing we want to check our answer, so what we can do is we can take this value of 7 over 9 and find the inverse cosine of this. As I showed you, that it doesn't give us the exact value, so that doesn't help us in finding our answer, but this is going to help us in checking our answer. So that gives us an angle in radians of 0.796. So what I'll do is I'm going to save this, I'm going to store this as A. Okay, so that's now stored in my memory as A. Okay, that value, that's cosine t. Okay, that's t. Okay, so t gave us this value, which, as I said, was stored. So if I want to find that what I stored, I can go recall A equals 0.67967. So 0.67967. Okay, something like that. Okay, it goes on like that. But we've got the kind of like the exact value stored because we kept it as it is in the calculator. Now, if this is correct, then when I put this into this equation, I should get the same value as that. It won't give me the exact value. It will give me a decimal value. It won't be an exact form, but it should give me the same value. So I'm going to put this in this equation as it's stored in my calculator, the same way, 967. Now that should give me something that is equivalent or equal to that in its value when we work out the value. So what we're going to do is I'm going to put 3 times sine of the angle that I have stored under A, okay, plus 2 times cosine of that same angle that I have stored. So I'll recall A. Okay, so that's basically taking the value of t that we found and putting it into this equation here, and hopefully that should give us the same as this. Now that's 3.4411. So 3.4411 ... Now if I can also store this as b, for example. All right, now if we're correct, then this should give me exactly the same value as what we saw on our calculator there. So let's see what this gives us. We have 12 times root 2 plus 14 divided by 9. Now, when I press SD, it should give me the same thing. And it does. So we can be rest assured that we have done it correctly. So this is like, what we've done here is like a little check. If you get time, you want to make sure that you haven't made a silly error somewhere, you can check to see if your answer is correct. As I said, I am doing this without the mark scheme because it hasn't been published at the time when I'm making this video. So that's why I am actually going through these checks with all the questions to make sure that I haven't made a silly mistake, which is something very easy for anyone to do. Okay, it's very easy to make silly mistakes. So there's the answer for question number 7. Other questions from this paper can be found in the link that will appear in this area over here at the end of the video. Other questions from this topic of parametric equations and also differentiation. So you have parametric equations and also differentiation will be found in these 2 places here, and you can subscribe to my channel by clicking on that link. Thank you for watching, and see you soon.